Thank you for this possibility to present my project. Penelope, a study of weaving as technical mode of existence. It's an ERC consolidator project funded by the EU. It will run 5 years. We hope it will start in December or at least January next year. I'm the principal investigator, and the team consists of Alex McLean, who is organizing this festival. Flavia Carraro is an ethnologist and anthropologist, and Giovanni Fanfani is classical philologist. And from these both you can see that the project contains also classical studies, but today I will concentrate on the technological part. The host institution is the Research Institute for the History of Technology and Science, Deutsches Museum Munich, which is one of the biggest science museums in the world. Partner will be a museum for plaster casts of classical sculptures, and you will see some photos that were taken in the museum. So it's maybe interesting to know where this was. You can unfortunately not see the background picture. I have it once more here. Our focus is not on weaving in industrial times, but in antiquity. And as the title Penelope indicates, mainly on archaic Greek. Here you see a Penelope statue on the right and a loom on the left, and this is the loom that they used in ancient times. It's called a warp-weighted loom, and it's standing upright. What you saw in the announcement with this machine, which is something very different, this is a machine we call pattern matrix. You saw it, as I said, on the announcement, and it's a computer with a keyboard for making patterns. We made this in the Weaving Codes project, which is a preliminary project I did with Alex. And here you can see the Arduino boards and the Raspberry Pi. I come back to this machine later. Our vision is to explore ancient weaving technology by inventing and building more of these digital tools that help us understand what was going on in an ancient weaver's mind while she was executing her algorithmic and mechanical movements in creating patterns. A little bit is lost because of the presentation, but here you can see this is a vision of the project results, so to speak. You see a live coder sort of here. This is the loom, and we try to make, so to speak, a mechanism doing the movements. So to split up the ancient weaver into a lot of different parts, so to speak. But why ancient weaving? Okay, I can show, maybe this is interesting. So we have these parts already. We just have to close the gap. But just is, it will be difficult, I think. What do we mean by technical mode of existence? We follow the idea of David Boulter, who coined the term defining technologies. These are technologies or technological innovations that define or redefine humanity and its relation to the world. Usually one can detect them by paying attention to the metaphors used for describing the world and its order. Today we use a lot of metaphors from digital technology. We think of our body as a sort of execution of code stored in our genes. We explain the function of the brain by using metaphors of electricity and network and so on. In ancient Greece, spinning and weaving were the defining technologies used to describe the order of the generation, the order of the city-state, but also poetic composition and the order of nature and the cosmos. You probably all know this quote by Ada Lovelace: "The analytical engine weaves algebraic patterns just as the jacquard loom weaves flowers and leaves." She made an explicit connection here of the analytical engine and the jacquard loom. We heard yesterday that weaving is mainly threads going over and under each other, and that this binary feature of weaving is the reason for the invention of the punch card control mechanism. But then, weaving is binary from the very beginning. And therefore, I state that the ancient loom calculates algebraic patterns just as the computer calculates images and information. I cannot explain in detail this slide. You see that I try to show the generation of the fabric as a mathematical formula, so to speak. And this is quite easy to understand. So these are the warp thread, the weft thread, the up and down operator, so to speak. And this is the result, which is usually tabby. But you can also do something like this. Mix warp threads and weft threads. Use this as an operator, and you get actually this type of pattern from that, which is a pattern that we actually find on ancient vase paintings. But, so what, okay. There are important differences in nowadays and ancient weaving that make calculation essential for an ancient weaver, but not for a textile designer today. I indicated here the ancient weaver uses a continuous thread, which we don't do anymore today. The first difference is the framing principle. A band or border is running around the cloth, and that determines the number and length of warp threads from the very beginning. You can see it here, this orange-like thing that's running around, and the black threads are integrated there, so they are not attached to the loom. I skipped this, it's too complicated to explain. You can see the same principle here. This is a small tablet woven border. This is a broader one, and this is looks like usual tabby, but it's a double cloth actually. So it's possible to combine different textile technologies on this loom. And following this, the logical rules and the constraints for making patterns are much stricter and stronger than today and demand far more arithmetical and topological consideration. Today, programs for weaving design work like Photoshop with a paintbrush, or you can see Bezier curves and pencils and smudge fingers and airbrush and something like that, which I do not use as a weaver. They do not allow concepts of framing the fabric. They do not allow combinations of different technologies in the weave. They do not allow to change patterns during the weaving process and do not show the continuity of the thread. This was the reason for inventing the pattern matrix machine. The other one was that, simple as weaving may look like, it's very time consuming, and we looked for a possibility of simulation. So, yeah, you see Alex and me sitting in the museum. We tested and programmed the machine on this occasion. We also did a live coding session there. Here you have a close-up. Sorry for the pixels. You can maybe see that you have a cross of dark wooden blocks here. You can turn around these blocks for programming the machine, and you see the white thread is then running just through, so the movement is simulated. And you can also see that here we have a continuous thread, but we have still problems in programming that. Here you see the thread going on, but changing color, which is of course not what we want to have. The movement of the weft thread, as I said, is simulated on the screen, and I can intervene in the process by changing the pattern, like the live coder can change the score while it's being executed. And that's something we did in the museum for a live coding session. You see Alex, and maybe you know Dave Griffiths. And I'm the first, it was really premiere, working on this for making music. And of course, the pattern it generates then might not be weavable anymore. So this is the idea, as I said, to explore weaving technology by inventing and building more of such tools, and to understand what was going on in an ancient weaver's mind while he's executing this pattern generation. So that's it. Thank you. Yes, I'm sorry that you cannot understand everything in 10 minutes when I show it like that, of course, yes.
So what do you think was going on in ancient weaver's mind?
I actually think that this is called a festival of algorithmic and mechanical movement. And our idea of weaving is actually to get rid of this, because that is just boring and time-consuming. So, but I think actually that this can put you into a state of sort of maybe meditation, or maybe better to say awareness. I did this, and of course you get tired, and then you are not attentive to your pattern anymore. So there is really a very interesting balance of creating and following just rules at the same time. And that's what I'm interested in. And I think we do not really know how that works. Some call it tacit inference or implicit knowledge or something like that. It's very difficult to express with our concepts of thinking. And that's what I'm interested in. Yeah.
So what do you think you can, if your project is to gain insights into the ancient mind, the weaver's mind, how can live coding support that? Or what can live coding do to shed light on that?
The interesting thing about live coding is that you don't have to, it's a simulation problem. So as I said, as a researcher, I'm not allowed to do weaving all the day. I'm not paid for that. I could pay a weaver for doing that, but this weaver does not have the idea of ancient structural patterns, and also not of ancient mathematics. So I studied mathematics, and I know how ancient mathematics works like, and I didn't present that today, but ancient arithmetic is quite different. They have a sort of dyadic arithmetic, which no one knows where it comes from, and I think it comes from weaving. And to understand how this dyadic arithmetic, which is very uncommon to us, works when you do pattern weaving, that's an interesting thing. And for shortening that process, I thought of simulations. And as I showed, I cannot use the modern CAD programs. It's absolutely impossible. So I was looking for people who can, because when it's true that weaving is so binary from its very nature, we should be able to use computers for doing this without all the software stuff that we generated in between. And therefore we try to do this very direct approach, maybe even use transistors for simulating that. It's not really answering the question. So the live coding is that you can change the pattern while executing. So you are doing something like composing, and that's actually what the weaver also does. Composing patterns, and the ancient weaver can change the pattern on the loom. But the modern weaver cannot do that, and that's the difference. And therefore I need live coders to help me with this algorithm, so to speak. Yeah.
Okay. I think we've got one more question, and then we should.
I've been reading around some weaving stuff, and one thing particularly that I've come across is called network drafting, and it seems to be a sort of second-order mathematical thing, which allows you to produce more complex patterns without using a Jackson. I can't find much information about it other than one particular author. Can you give a very
it might be that I know what you're talking about, but I'm not sure about the words. It might be translation problems from German to England. In Germany, the drafting techniques that we still use today were invented, but before there were a lot of other drafting technologies. Maybe you mean something like that. We should talk about that.
Is the author particularly interested? Alice Schrein, I think, is the author.
No, I don't know.
I'll talk to her.
Yeah, we can talk about that. You can really approach me afterwards and ask your questions still. Okay.
Thanks very much.